Okay, this is the last video for the FE lab. So we're gonna start with the model from the second lab, and you will need to do the element edge check and show adjacent check and make sure they are correct. Okay. So the next step we're gonna start to make the nylon bar, and here's the final results. And let's go to the FEM. So there's one thing we haven't created in the FEM is the nylon bar, which the clamp will apply force on. And so I'm going to delete this. So your model will look like this. And to insert the nylon bar, we need to first insert one node in between. So we'll be able to apply the fixed constraint on that. So the nylon bar will be on the XY plane, and it is pretty hard to find where XY plane is on along this edge. So what we do is we turn on the section. Okay. So we'll cut this model in half, which should be on the Z direction, and make sure this Z direction is at Z equals 0. And we say OK. So that's your symmetry plane, and we'll insert a node which is between two nodes. And the two nodes, there should be one node right on the XY plane. So that's and this one. Okay, so there's another one. And keep in mind that the graphic got cut in half as well. So there's a node. Then we might as well just insert the C bar while this cross section there. So insert element, great. Then we do a 1D C bar. We need a new collection because it's a different material. And start from here to here. Then from the center, you can add to existing mesh. Okay, so we'll have one mesh for the C bar. Okay, two elements, one mesh, and close. Now the next step is to give this a cross section. Okay, you probably have P bar 3 or a little smaller number here. Okay. Then the cross section here is actually the same as the smaller pin. So if I remember right, that should be rod 1. If you're not sure, you can come in here and use this information to show the radius of the rod. So in my case, my second rod is 0.1 inch, which is the one you want. Okay, so radius 0.1 inch. Okay, and you probably have that as rod 1. Who knows? You have to check. And material is nylon. If you haven't used that, you have to come into the material library and choose nylon. Okay, so now you should be able to see the C bar. Then we probably want to change the display into curves, so it's a little easier to see. Okay, then we can turn off the work section. Now here's the whole FEM is finished. Then we'll go to the sim, and in the sim you should have nothing. Okay, which I have something here already, so we'll delete these. You should have your model like this, and let's see. So first let's apply the load. The load is 10 pound, squeezing the handles opposite direction, and they should be on the positive and negative x direction. All right, so we apply the force, and this force should be on the symmetry plane, which is XY plane. And again, here it's hard to find the middle of your handle, so we can open the 2D mesh Remember, our handle is reflected. You can turn off a half. You can also turn off a half for this side. So that's the middle of your handle. We'll pick this node and apply 10 pounds. The direction would be negative for the right side, and apply. And for the positive, the left side, that will be positive x direction. Okay. Then the constraint. We have the first constraint is fixed constraint, and we want everything move with respect to the center of the C bar. That's why we inserted one node there. So the constraint is fixed constraint, and pick just this one node, and okay, that's very simple. The next one is we are gonna grab a random point on your model as long as it's not in line with the C bar, so you cannot grab those two. To maximize the effect, we'll just grab one on the handle. Okay, in anyone node, just click anywhere. Then we'll kill degree of freedom 3, and the reason has been explained in the class as well as in the slides, and you have to know why. You will be asked this question. Okay, so kill degree of freedom 3. All right, then we need to output the forces in the joints. So how do we output the forces in the SPs? Okay, first we create a group. Then we'll be able to pick that group and ask NX to output these forces. I think I have one here already. Anyway, so you create a new group, and you want to select the SPs. So here you open the 1D collector, open C-Bush collectors, and select all 5 of them. You don't have to hold any keys, just simply click, and we have one extra needed for the output group is the nylon bar. So with this selected, we will be able to see the forces inside of the nylon bar. Now we have 6 meshes selected. In case your your nylon bar has 2 meshes for each of the element, you would have 7. So we have 6 elements or 6 meshes in the output group. Okay, I'll just delete the old one. And next is enable the force output. So we created the group. Next, in the solution, we want to put them into your FO6. So probably what you want to do is, before solve, you might want to do a model setup check. You know, it's a usual things, and make sure there's no error. And the warning is fine, don't worry about that. In case you have a lot of errors, I recommend you go to the last page, okay, or the page here to find that troubleshooting PDF to look for the solutions for any errors you would encounter in the model setup check. Alright, so let's enable the force output. We'll go to solve, edit the attributes, and go to case control, output request. So here first we want to turn SPC force into print. Okay, so we'll know the reaction force for your constraints. And then the second one is we'll enable the force, change that to print. And the next thing is change the output entity to groups. And then we'll select the group we just created. So that'll be group 2 in my case. In your case, it'll be group 1. That's okay. And okay. And just go ahead and solve it. So it'll write the forces in the joints and in the bar into your FO6 file. Then you'll be able to see them. Then you can compare that to your hand calculation we did in the class. And let's see, you should get some results like this. Okay, is it running? Yeah, it's running. Okay, then you can compare this to your homework 11. Yeah, I don't know if we can see numbers here. Okay, so one thing you have to be careful is the sign of the forces in the bushings. The sign can be flipped. For example, we have a negative 6.7 here. It could be positive. The sign doesn't matter for this in this case, because I don't know if you remember, I said before the C bush doesn't have a positive or negative direction because of the way we created it. So you could have positive numbers or negative numbers as long as the magnitude is good. Okay, so that is for the forces in the bushings. And you have the C bar force, the axial force, which is the clamping force from the jaw. Okay, so 149 pounds. Then one thing to check is also the SPC force. The SPC force should be very small, so -8, e to the -8. So that is pretty good. Okay, if you see 1 pound in SPC force compared to 10-pound load, that is very bad. And the last thing is once this model is done, okay, so it seems like it's pretty slow. All right, so once the model is done, and when you're looking at the displacement and you want to take a picture for the report, you need to add your name into it. If you don't have name, you don't have points for that picture. So you can right click on the post view and edit this post view. It'll give you the it'll give you the option to change the header, and you can add your name to that. So this is pretty much all everything in this class. And yeah, so you'll be asked to show different things for the results. We might have another video for that purpose. Okay, so it seems like I can't finish this in time. We'll just take a look if we have anything here. So let's say we finish the calculation and the gut displacement, and you want to show your name here. You right click, edit. Okay, change the legend into customized and open that legend. You can add your name here and say okay. It'll show up here, right? So you need to definitely take a picture of the displacement, and you probably will need to take a picture of the stress for one of the parts. So how do we show this stress for only one part? You can open the post view, turn off the element that's not necessary or that's not needed. Then we'll just show one part. Okay, and sometimes you need different types of stress. We need maximum principle, usually for this case. So you can see that's a little bit stress concentration there. So all of this is going to be in the next video, and what the report is going to need for stress. Okay, so thank you for watching.